Hello guys, and welcome to the 11.4 notes on the Pythagorean Theorem. Okay, hopefully you can hear me okay. I am filming this actually here in good old PASD. But anyway, moving forward here. Pythagorean Theorem, I think you experienced this before in middle school, correct me if I'm wrong, but it should be pretty easy. And basically our central question is, how do you use this theorem to find missing sides of right triangles? And this is where it gets a little more realistic. A lot of our word problems and applications will follow the Pythagorean theorem. Pythagoras was a very interesting mathematician. Maybe some divorcee dollars if you look up Pythagoras, okay, and bring some information about him. Pythagoras, I think, something like that. Anyway, his famous theorem is that a squared plus b squared equals c squared. And what are these different variables and such? Well, a is a side of a right triangle. B is the other side of a right triangle. Okay, and C, the key thing is always the hypotenuse. Hypotenuse. Okay, so labeling these, it's always important to know, okay, the hypotenuse is always opposite of your right angle. We always designate triangles typically with right angles. When you get into geometry, that has to be there in order to know it's a right triangle. And basically put, I'll use the colors here. This here is going to be our C. So 15 is equal to C. That's always the hypotenuse. A and B, it really doesn't matter which side you connect to. So I'll let 9 be A. And I will let X, the missing side, be B. Okay? And basically, you're just plugging it all into Pythagorean's theorem. Okay? You're just going to substitute all that information in. So what we have is a squared, which is 9. So 9 squared plus b squared, which we don't know yet, okay? B squared or x, sorry. You can either have b or x squared equals c squared. And c, again, if you want to rewrite it, sorry, is 15. Okay, so you might have to erase. This is our statement, and simply put, we're going to solve it. So 9 squared, if you use your cards, you should know is 81. And then we have plus x squared, which we don't know, equals 15 squared, which 15 times 15 is 225. We are going to solve for x squared. And doing that, we're going to subtract 81. 225 minus 81 is a good old 144 equals x squared. And hey, how to get rid of an x squared? Remembering from last chapter or last lesson, we're going to then square root each side. So x is 12. Okay, square root of 144 is just 12. Really, what you'll get into next year, it's really plus or minus. But in our case, we are considering positive 12 because it's the side of a triangle. Okay, you can't have a negative side length. So it's just plugging into a squared plus b squared equals c squared. Sometimes different pieces will be missing. Down below here, notice, okay, here's the right angle. So labeling A, B, and C, 9 can be our A, it doesn't really matter, or B perhaps. 7 can be A. And again, the hypotenuse in this case is what's missing, so is C. Putting it all into the formula from above, we have A squared, which is 7 squared, plus b squared, which is 9 squared, equals c squared, which is x squared. And in this case, we have 49 again, plus 81 equals x squared. On the same side, we have good old 49 plus 81, which is 130. Now, here's where more of our root stuff comes into play, equals x squared. Okay, now this is why we're doing this a little bit last. We need to simplify the square root. So we're going to, again, square root each side. Square root, and here you need to think, okay, what are perfect squares that go into 130? And actually, there are no perfect squares. There's no perfect squares. So our answer is simply x equals the square root of 130, which is approximately, if you type in your calculator, so sometimes I will ask you for what it is approximately, and it helps with our word problems, which is about 11.4017, okay? But this is the exact answer, and this is approximate, okay? If this could break down, you would want to break it down if you could. But in this case, you can't, okay? A roofer knows that in order to safely use a ladder. So here's more of our real world. There actually are a lot of different triangle problems out there, okay? A lot of what we deal with is triangle, and you'll actually take a whole class on called trigonometry, which is all based off of it, okay? So a roofer knows that in order to safely use a ladder, it must be placed 6 feet from the edge of a house at a right angle. Well, that means that 6 feet from the edge of our house, okay, he's got to put it 6 feet from the edge, okay? So there's our 6. He needs to reach the roof 12 feet above ground level in order to apply new shingles, okay? So the roof here is 12 feet tall, okay? And the question is, if he has a 15-foot ladder, will it be tall enough, okay? So really a little bit of applying here. So I just illustrated the diagram for us, 6 and 12, if it's hard to see. And basically, you have A, B, and C. Okay, so 6 squared plus 12 squared equals the ladder squared, or C squared. 36 plus 144 is equal to C squared. 36 plus 144, bada bing, 180 equals C squared. Now, I'll let you know, let's look for an approximate answer. So again, to find C, we square root each side, boom, 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 and we find that it's square root of 180 is about 13.42, okay? So we found that his ladder is actually 13.42, or that's the distance he needs to go. So a 15-foot ladder, if that's what he has, he needs to go 13.42 feet. His ladder is 15 feet, so he's good. So yes, he can apply the shingles or paint in our case. And really, that's all it is, okay? A squared plus B squared equals C squared. What I'd like you to do is try out this problem. Okay, A squared plus B squared plus equals C squared. And try it out. Bring your work to class for it. Show me it. And also make sure you go on the Google Classroom's website. And the essential question is, how do you use the Pythagorean Theorem to find missing sides of right triangles? I would like you to answer this on Google Classrooms. And I also want you to give a made-up example that maybe in the future you will end up using the Pythagorean theorem. So give an example from the real world. Be creative. Okay? So 2 things, essential question, try this problem out, and you should be in awesome shape. Pythagorean theorem. Oh yeah, check out Pythagoras for maybe some D money. Bring some stuff for him. So good stuff, guys. Thanks, and see you later.